is SM3, Chapter 3B review, starting at the very first one. We'll see how this goes. I don't know if I'm going to have enough space in here, but I'm going to do my best. Okay, so number one, what are three other words that mean the solution of a polynomial? Well, we have zeros, so we have a zero, we have the root, and we also have x-intercepts. Okay, number two, according to the fundamental theorem of algebra, how many zeros does this polynomial have? Okay, the thing you've got to remember is that it's always the highest exponent. It's the degree of the polynomial. So in this case, there are 6 zeros, or 6 solutions. Using the rational root theorem, list all the possible roots for this polynomial. Okay, remember, the rational root theorem means I take the factors of the constant, meaning just the number on the end, right here, over all the factors of the leading coefficient. Okay, so in this case, I've got the factors of 10, plus minus 1, plus minus 2, plus or minus 5, and plus or minus 10. Okay, and then I've got the factors of 2, which are plus or minus 1 and plus or minus 2. So now I need to put all of the ones on top over 1 and all of these over 2. So I've got plus minus 1, plus minus 2, plus minus 5, plus minus 10, all over 1. And then I have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, all over 2. Well, the thing that I need to see now is that I've got 1/2, but 2 over 2 is the same thing as 1. I already have that. So that can go away. Then I've got 5/2, and then I have 10/2, which is the same thing as 5, so that one can go away. So I've got a total of 1, 2, 3, 4, 5, 6. 12 if you count the plus or minus. Okay, a polynomial of sixth degree could have at most 5 turning points. Okay, so if I had, say I had a polynomial and it had 6 real roots, say 1, 2, 3, 4, 5, 6, and it literally went like this. Okay, then I have 1, 2, 3, 4, 5 turning points at the very most. Okay? Given the function f of x equals 3x times x, anyway, this function right here, what is happening at each x-intercept? And what I meant by that is, does it go through the x-axis or does it bounce? Well, this first one, we have one that goes through 0, right? That one's right here. This one has 2. So we've got a bounce at x equals 2, so at 2, and a bounce at -3, okay? And that's because of these 2's that we have right here. If I've got 2 there, it means it's a bounce. If this was 3x squared, then it would be a bounce at 0. Okay. How many imaginary and real solutions are there in the following? Okay, we talked a little bit about this in class, but I have a total of 3 solutions in this problem. According to the fundamental theorem of algebra, it's the degree of the polynomial, so I have 3. And I know that the one that crosses the x-axis, or the ones, any of them, are the real roots. So I only have 1 real root, but I have a total of 3, so that means I have 2 that are imaginary. Okay, over here I'm going to have a total of 4. It crosses twice, so I've got 2 real and 2 imaginary. Okay. finding the zeros of a function. This is where I hope I have enough space. I may not. Okay, so this first one, I got to get everything over onto one side. I've got p cubed. Okay, this one's going to move over, so plus 2p squared minus 25p minus 50 equals 0. So this one I can actually factor by grouping. So I'm going to factor out well, I can divide it like this. Factor out a p squared, and I get p plus 2. And now I can factor out a negative 25, and I have p plus 2 here, right? Because negative 25 times 2 is negative 50. So I'm left with p squared minus 25 times p plus 2 equals 0. And I can factor this down even more. P plus 5, p minus 5, and then times p plus 2 equals 0. So p equals negative 5, positive 5, and negative 2. All right, so for this one, I think I mentioned in class that we can factor out an x, but the rest has to be done by the quadratic formula. Okay, so if I factor out an x, I'm left with x squared plus 2x minus 7. And that is not factorable. So I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And in this case, a equals 1, b equals 2, and c is negative 7. So I'm going to start plugging those in. So I have x equals negative b plus or minus the square root of b squared is going to be 4 minus 4 times a times c over 2a, which is 2. So now x equals negative 2 plus or minus the square root of, this is going to be 4 plus 28, which is 32 over 2. And this is where a lot of people got confused. Okay, the square root of 32, we need to simplify that, and it equals the square root of 16 times the square root of 2. And 16 is a perfect square. So the square root of 32 is actually 4 times the square root of 2. So when I put that in, I have negative 2 plus or minus 4 times the square root of 2 all over 2. And now I divide, through by this 2, and I have x equals negative 1 plus or minus 2 times the square root of 2. These are two answers, remember. One is negative 1 plus 2 times the square root of 2, and the other is negative 1 minus 2 times the square root of 2. So there's two answers here. And then my original, I come back up here because I've got to have 3. Then over here, I have 0, x equals 0. So those are the solutions, the roots or the zeros to that problem. And let's see, that was through 9. I'll start with number 10 on the next video.